Hey, this is Workbench Quagmire, back with our free code camp Python certification in 100-ish days. It is day 90. We are down to the finish line here. Today we're going to be going over this implement the in queens problem lab. And do a little research on this one too. The in queens problem asks you to place in queens on an n by n chessboard so that no two queens attack each other. So no two share a row, column, or a diagonal. For example, if there is a 4x4 board, one valid arrangement is 1, 3, 0, and 2. That means that in row 0, the queen is placed in column 1. In row 1, the queen is placed in column 3. And in row 2, the queen is placed in column 0. In row 3, the queen is placed in column 2. Visually, this is what the arrangement looks like. So column 0, 1, 2, 3, row 0, 1, 2, and 3. Where the Q represents a queen and a dot represents empty space. In this lab, you'll implement an in-queens problem solver using the depth-first search approach. Objective: fulfill the user stories below and get all the tests to pass to complete the lab. So here are the user stories. Here are the tests. Let's go ahead and put this test in here. It's going to complain, but that's okay. That way we can kind of see what's going on as we build this thing up. Okay, we need a function called DFS in queens. It takes an integer. Let's see. Oh, it takes a board. No, it doesn't. What does it take? It takes an integer. In. And then the function should accept exactly one argument in. If it is less than 1, then the function should return an empty list. So there, the function should return a list of solutions. Each solution is itself a list of length n, where the element at index I is the column index and 0 based and queen and of the queen in row I. So solutions will be a list, and ultimately we're going to return solutions once we determine them. Go. Okay, let's create a function to determine if a row and column is safe on a given board. So we're going to define is safe, because that'll be where we apply our queen. Board, row, column, and then row or I in range row. We're going to check the column. Is there a queen in the same column? Check diagonals. Is there a distance between the rows equal to the distance equal to the columns? That's how we check for the diagonal. So if board I equals column, or the absolute board I, we're checking for the diagonal here, minus column equals the absolute I minus rho. Just checking, saying, is this the distance is the same? There we go. It's a little cleaner. Then we say if... Nope. Then we return false. So basically, if it's in the same column or it's in a diagonal, it's false. And that's for each row we're checking. Oh, we don't have our indentation correct here. There we go. Now we need to have a solver function. We give it a row and the current board. And then for the solver function, there's solve function. This is going to be, we're going to use this in recursion. We're going to call this with a default, and we will basically starting a 0 row for a blank board. So we need to have a base case. So if the row, if there are no more rows, or no, if there's base case is if we placed queens in all the rows, we have found a solution. So if we've gone through all the rows and we've had placed the row number equals n, which is the number of queens, then the solutions dot append list. I'm going to turn this into a list of the current board. So there's our base case. Now we're going to go for column in range in. So this is the recursive step. We're going to try to place a queen in each column of the current row, and then we're going to check to see if it's safe. So we're basically calling the is safe over and over again on each row in each column. Safe, then we're going to append to the current board the column. So that'll be the column we put a queen in. We place the queen. So then we recursively call it solve row plus 1. So we go to the next row and we give it the current board, which now has 1 queen on it. And not pop. So backtracks, so it removes the queen. And then down here, we start this whole thing by calling it on a 0 row of the current board, which is empty. Oh, it's returning none because we never return true here. There we go. Forgot to return true. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.